Spend a bit of time over a few clear nights and you'll notice some movement in the stars. They rise in the east, they set in the west, and they arc across the southern sky, rising in the southeast and setting in the southwest. But now look north and there's something a little bit unusual going on. In the northern sky, we see the stars wheel anti-clockwise slowly around one star that doesn't appear to move. That is the North Star. It is due north. The point on the ground vertically below the North Star is due north. To find the North Star, there are certain shapes we can use that will guide us towards it. Think about when you look at a map of a region you know fairly well. If somebody says to you, find a city, you look for shapes, coastlines or countries that you recognise, and then from there you can find the capital city. It's the same method in the night sky. Instead of countries, we use constellations or shapes. The first one to look for is called the Plough in the UK, the Big Dipper in the US, and there are lots and lots of other names for it all across the Northern Hemisphere. It's the shape that's important, not the name. It consists of 7 stars, and actually the shape I find easiest to remember and teach is to think of it as a saucepan. The saucepan has 3 stars making up the handle, and then 4 stars making up the pan itself. If we imagine the pan has some milk in the bottom of it, if you lifted the handle, the 2 stars that the milk would run off are our pointer stars. Those 2 stars will show us the direction we need to look to find the North Stars. But it also shows us how far we need to move our eyes. We go from the bottom star to the top star, and then 5 times that distance in the same direction. 1, 2, 3, 4, 5. There, in that part of the night sky, you will find the North Star. It is always on its own. It is not the brightest star by any means. It's roughly the same brightness as the 7 stars you've just been looking at. And directly below that star is due north. The second shape or pattern that can help us find the North Star is actually on the opposite side of the North Star from the Plough or Big Dipper. And this is really useful. Remember, the stars rotate anti-clockwise around the North Star. So when the Plough is low in the sky, this other shape will be very high. Cassiopeia will be very high. So how do we find Cassiopeia? Well, we look for a W. There are 5 stars in Cassiopeia shaped like a slightly stretched W. And once you've found Cassiopeia, once you've found that W, all you do is imagine a tray across the top of it, and then that rotates 90 degrees anti-clockwise around the top left star. And then you double the length of the tray and you're at the North Star. Remember that Cassiopeia is rotating like the Plough is around the North Star. So sometimes it will appear as a W below the North Star, sometimes as an M above the North Star, and at certain times it will be on its side. But the shape doesn't change and the relationship to the North Star doesn't change. So once you recognise the shape and you know this method, you can use it to find the North Star. You might be curious to know why the North Star works. Why does it help us find due north? Well, what I'd like you to do is imagine that you've arranged to meet somebody under a lamppost on the other side of a gently curving hill. As you walk towards them, you can't see the lamppost or the person you're meeting yet. As you get a bit closer, suddenly you can see the lamppost. It's shining above the horizon, but you can't yet see the person. But if somebody asked you to point towards that person, you'd be able to do it. You'd say they're there and point towards the lamppost because you know they are directly underneath the light. Exactly the same principle works with the North Star. The North Star doesn't move because it is directly above the North Pole. The North Pole is the axis that the Earth is rotating around. That's why the North Star doesn't appear to move. And the word north means towards the North Pole. So our lamppost on this occasion is the North Star. And when we point towards the North Star, we know we are pointing at something, and directly below that is the North Pole. So that is why we're pointing north. In the winter months, there's a really helpful constellation that can help us find direction, particularly east and west. Orion, the hunter. Everybody will have seen it even if you didn't know it at the time. Orion rises in the east, moves through the southern sky and sets in the west. Orion has a belt, 3 stars, and they're quite easy to spot. They are the only 3 stars that are quite bright and form a short straight line, the only ones in the whole night sky. The first star to rise is called Mintaka. The name's not important, but that rises very, very close to due east, within 1 degree, and it'll set within 1 degree of due west. As Orion arcs across the southern sky, there comes a moment when you can use him to find south as well. Hanging off Orion's belt is the Sword, a series of stars and also a nebula, and when that hangs vertically, it is pointing due south for you. In the southern hemisphere, things are a little bit more challenging, mainly because there isn't a star that points due south for us. What we need to do is find a constellation, a famous one called the Southern Cross. The Southern Cross points to the spot that is due south, but unfortunately there isn't a star there. But we can still use it. You go from the star at the top of the cross to the star at the bottom. Those are our 2 pointers in this case. We go in that direction 4.5 times the length of the gap between those 2 stars. And it points to a fairly dark region, but that is due south. It is more challenging to use, but it works. Using the planets to find our way is actually quite difficult. The main reason is that they have their own years. They take their own time to go around the sun, which means we can't predict with any authority what direction they're going to be exactly without looking at tables. And we're not going to do that. So what we can say is they will rise in the eastern sky and they will set in the western sky and they will arc through the southern sky. In truth, the most practical use of planets is for holding a course. So what I find is if I'm on a night walk, the brightest thing very often is a planet, like Venus for example, and having worked out what direction that is, quite often using the stars, I can then hold my course. I might be thinking, okay, I'm going to walk towards Venus for a while, or I know that Venus is on my left. Because it's the brightest thing, it just helps us keep tabs on what's going on around us. The North Star is giving us a fantastic sense of direction, of course, but there is something else very important that it's trying to tell us, and that's quite a simple method for working it out. The North Star gets higher in the sky the higher your latitude, the further north you go. If you were standing on the North Pole, the North Star would be directly over your head. That is 90 degrees up from the horizon, and you are at 90 degrees north. At the equator, if you could see it, the North Star would be sitting on your horizon. It would be 0 degrees above the horizon, and the equator has a latitude of 0 degrees. And that relationship holds over the whole of the northern hemisphere. As we go north, our latitude increases and the North Star gets higher in the sky. And there is actually a natural navigation method for assessing approximately how high the North Star is, by which I mean the angle it is above your horizon. All you have to do is find the North Star and then stretch out your arm and make a fist with the thumb on top, and that will make approximately 10 degrees. You then line up the base of your fist with the horizon and count how many fists it takes to get to the North Star. 1, 2, 3, 4, 5. 5 fists, 5 lots of 10 degrees. The North Star is 50 degrees above the horizon. Your latitude is 50 degrees north.